Good morning, everyone. Thank you for coming in on an early Thursday morning for our presentation and our talk here. I am Sid Gambhir. I am part of Accenture AWS Business Group, so I represent our team that partners with AWS. And today I'm very, very excited to bring a story of a real client collaboration with AWS for you. This story centers on what we call total engineering reinvention. Here at the Hannover Fair, there's a lot of talk of Industry 4.0, robotic arms running right in front of me, but this story focuses on the engineering product development side of the manufacturing value chain and the role that's played by the cloud and various tools that are already active and needed for engineers to develop their products and for R&D functions. Today we will talk about this concept of total engineering reinvention, something that Accenture really sees as a transformative force in the Industry 4.0 landscape and helping our clients transform how they build products, how they design products before they're manufactured. We will take a specific case study example of model-based systems engineering, or MBSE transformation for an aerospace and defense company. And a lot of the client challenges and situations that I will describe, frankly, are very applicable to all aerospace and defense companies, certainly, but also companies that manufacture, make complex systems that have a lot of mechanical, a lot of electrical, and a lot of other components that all have to work together. We will talk for this particular client how we brought a very repeatable, standardized approach to solving for their problems and really showed them and helped build confidence in the technology landscape at their disposal by building a quick proof of concept solution to prove out our proposed architecture, of course using the AWS cloud. So as we begin, let's jump in and talk about what is this notion of a total engineering transformation. If we take a step back and we look at what is happening in the market currently, there's a lot of forces that are colliding at the same time. We've got multiple technology curves with chip costs going down, the rise of AI, cloud, of course, has been there for some time, IoT sensors, and et cetera, that are all colliding and making the product more complex. At the same time, customer expectations, even in traditional industries, are changing very rapidly, and customers are expecting much higher level of personalization in their products than what was the case even until a few years ago. The end result of all this, and the competitive dynamics as well, the end result of all this is development timelines need to be compressed down from, let's say, 36 months to 6 months, less than a year. And that presents a big, big challenge for industrial companies and manufacturing companies. And as a result, much earlier on in the manufacturing value chain, they are really trying to target very, very steep and aggressive performance improvements in engineering efficiencies, right? Unlike maybe other functions today, this is less about just simple cost takeout. It's about improving efficiency of engineers, doing more with the same engineering talent and tools that you have. So we see an increasing need in our clients' product engineering operations for improving reuse, how they design and do R&D of products, really making sure that they have a focus on quality and getting things right the first time, being able to create an engineering process and a tool chain in such a way that you can be responsive to changing dynamic customer needs, and increasing requirements for capturing, reporting, and actually improving the sustainability metrics and sustainability impact of the products that are being made. A couple of years ago, we saw a lot of companies were starting to explore the usage of AWS and the usage of cloud in their engineering function. And it was more of an IT-driven initiative, meaning the focus was cost takeout, and the focus was, we have an enterprise cloud migration going on, and now it's hitting our engineering space. How can we minimize the disruption to our engineers? What we are advocating for is total engineering reinvention, which in our minds consists of two parts. First part is the cloud-powered engineering. Simply put, this is your PLM systems, your CAD systems today that may be running on-premise are moving either to a fully SaaS-based model or at least running in a customer's cloud environment, their own AWS environment, that starts to give them the tools for higher collaboration among engineers, a more on-demand ability to scale up and down the infrastructure, and hence they can move faster. The other side of the coin, which we will talk about today, is model-based engineering. And I won't go into the definition of what this is. It's a fairly established topic, especially if we think about the aerospace and defense space. But it really means how we think about the entire product as a model from the beginning of the engineering and R&D process. So focusing on model-based engineering itself, what are the challenges that we see, specifically with a lens on aerospace and defense companies today in the market? Why is it that they need help? Why is it that cloud plays such a critical role in enabling model-based engineering? Multiple factors, but I can point all of those factors or all of the reasons simply to the data explosion. So I'll start with the data silo topic that's on the top left here. The data that's required to build a model for a product that you're making, it could be an aircraft engine, it could be a washing machine, it could be an automobile or a subsystem of an automobile. Generally speaking, the data is very fragmented, is located in different silos, and that provides challenges in terms of data accessibility and being able to connect different parts of the engineering tool chain. Also leads to data quality issues and data ownership conflicts because you're not aware, or you're not sure of how, being able to access the data in those silos. It may be different vintages, different data formats, so data quality becomes a big challenge. And at the same time, the organization and the way the engineering operating model is set up provides natural barriers to collaboration and to sharing data that could be owned by different teams. Finally, there's also an issue of generally there's absence of a intelligent data foundation, a way for different teams in an enterprise, even within the engineering function, to share the data easily and more seamlessly. And all of that is really compounded by lack of an overarching enterprise strategy and lack of the right talent. Talent that not only understands the cloud side and how to use cloud tools to unlock the data silos, but also context of the engineering data itself. So these are a lot of the factors that are kind of magnifying the need for this overall total engineering transformation, and specifically in the area of model-based systems engineering. So let's dive into the specific customer case here. I'm talking about a particular aerospace and defense company where we did work with them, but as I mentioned earlier, this really is applicable to the industry at large. If we look at the A&D space and just take North America, for instance, as a starting point, they are compelled to rapidly adopt model-based enterprise capabilities. In a lot of cases, they're not really ready because of the challenges that I walked through. And the reason they are forced to adopt these capabilities is because of their customers. They are demanding higher degree of traceability and a higher level of data being shared with them, and also because of competitive dynamics. Ultimately, as I mentioned earlier, unlike some of the other functions where cloud plays a major role, whether that's sales, marketing, or HR, and what have you, this is not really a cost takeout play, or at least primarily a cost takeout play. The end business goal of the client here, and a lot of companies in this space, is to improve development times, faster development through simulations, through validation. It reduces a lot of checks manual checks or rework that you may need to do, reducing waste, improving higher engineering efficiency by improving reuse of different designs and different patterns, and then finally improved product quality, the quality of the end product, and all of this together leads to a reduction in the overall development cost. So these are some of the business drivers of why this is really taking shape in the market, and for this particular client, they were keen to rapidly improve how they go about enterprise-level model-based systems engineering. So how we helped. In this case, Accenture and our Industry X teams, we have the ability to go and take really a business-driven, use case-driven approach in a consultative manner, work with our clients to understand what their overall North Star vision is, why they're looking to do MBSC, what are the specific goals that are important to them. Is this a top-down driven initiative for this company? Is it more of a bottom-up driven initiative? Or is it more of an IT-driven initiative? And that also allows us to understand the challenges that they may be facing, either technology challenges or process challenges and what have you. So we take sort of a repeatable approach, in about, depending on the specific context, 8 to 12 weeks, we're able to go and land a team that understands the engineering tool landscape, right? What are you using for CAD and for SIS modeling and for PLM and what have you, understands the engineering processes very, very well and how the different teams and subsystems should be working together. And we're able to do a holistic functional and technical assessment. And as part of that assessment, we'll help them establish a North Star, help unearth key initiatives that they should implement, score those initiatives against a standard kind of scoring methodology for business value and complexity. And in this case, we also developed a long-term roadmap and solution architecture that reused some of the components that they had in place, other components that we recommended, and it was all underpinned sort of by the AWS cloud from a scaling perspective. So let's take a deeper look into exactly what the situation was at this client. As we went in and did the assessment, what did we find? Firstly, something that's very, very common in this environment, there's always multiple tools in play from different vendors, and these are, some of them may be having pre-built integrations, most of them don't, and a lot of it creates a lot of technical debt and requires a lot of focus and investment to maintain this complex tool chain. And if we've been engineers, or if we've worked with engineers, one thing I can tell you, the effort should be to minimize change, right? Don't like to change the way they do work that often. So what we found is there were multiple sources of truth. Going back to the data silo topic that I talked about a few slides ago, multiple sources of truth for requirement gathering. There were some foundational sort of MBSC capabilities in place that had been tried, POC'd, but again, the MBSCs needed to be, the modeling capabilities needed to be industrialized. And some of the specifics of what that industrialization needed were things like easy to use collaboration space, sharing models between different teams, and using the right technology to share data between these systems. And ultimately, there was also an interplay between the business stakeholders and the IT stakeholders. The business stakeholders were bought in on the value of model-based system engineering. However, they were looking for a solution that would be scalable to larger use cases, more data volumes and more complexity of data, and something that could keep up with the enterprise cloud transformation journey that has been going on and underway. So when we spoke with the engineering business stakeholders, lots of challenges, and they had some areas where they knew what they needed to do, but then others where they needed help with the different dynamics in play. So what Accenture actually did is we took, coming out of the assessment and what we found, the solution that we proposed, not only did we kind of draw it up, but we did a technical assessment of some of the components of the solution, and we spun up an AWS environment on the Accenture side, and we actually stitched together, you could say, an MVP version of the proposed architecture to prove out some of these connectors, not only for ourselves, but to also show them to the customer and to build confidence that what we are proposing can actually work and it can meet their needs and it can scale with their needs. So we wanted to minimize introducing new tools into the mix. We wanted to keep existing tools as much as possible to, again, reduce the technical debt. And as I spoke earlier, there's a challenge with the skills required to maintain such a system and such an environment. So the skills that they already had in place, we wanted the client to be able to continue to leverage those skills. So in this case, we proposed that Siemens Teamcenter, which is their standard sort of PLM tool, would continue to be the centralized application for the governance of these model-based systems. And we will, again, continue to use their existing tool for system modeling. The systems modeling tool and the collaboration environment for MBSC had native integrations. However, for some of the other tools in place, we, like I said, went through, did a quick evaluation, even during this quick 12-week assessment, and came up with the recommendation that because we had something running and we showed it to them, built a lot of confidence with the client. What were some of the benefits of this? So first and foremost, this was not just an assessment, right? We built an AWS-powered prototype of the proposed architecture to validate the key features and obtain buy-in from the business side that they would really be able to adopt this type of a proposed solution. Secondly, because we use a lot of existing tools that the client's IT organization had already approved from a security and compliance perspective, the proposed solution really built confidence with the client's IT teams regarding resiliency, the cybersecurity aspects, and the overall compliance, as well as the total cost of ownership. So those are two key stakeholders that we really needed to get on board with different factors or different things that they were looking for. The solution that we built in our environment, as part of that, we proposed, AWS allows you to create infrastructure as code. This is something that we recommend all the time. You build scripts and you're able to quickly deploy, maintain, and change the services that you have in place. So that allows for faster stand-up time of the environment, faster overall speed to market. I talked about the technical debt piece already because we were using the existing tool chain as much as possible. And also, we sort of found a middle path in terms of this was not I would call a simple lift and shift. It was not a ground-up modernization. It was somewhere in the middle where we used some aspects of what they already had in place that they were happy with, but then through the connectors and showing them the usage of cloud from a resiliency standpoint, security standpoint, and automation standpoint, we were able to bring some modernization elements into the proposed architecture. And ultimately, one of the key factors from a business stakeholder perspective was improving the collaboration between different teams and the traceability of how a particular model for a subsystem changes or evolves, and improving the traceability, which again builds confidence with the business stakeholders. So these were some of the benefits of the solution and the approach that we took. As I said, this was a fairly rapid assessment plus a technical solution that we developed and showed to the customer. Today, we continue to work with them in further scaling out the use cases that we have identified, further evolving the solution architecture that we developed, and that includes use case development, identifying new use cases, overarching roadmap, but also how to do configuration on some of the individual tools, and then the change management aspect of adopting MBSC among the business stakeholders. So with that, I want to thank you for your time and wanted to leave some time for questions as well. One of my colleagues was supposed to join me, but you had something come up at the last minute. So that's Vivek and Sid, myself. You can take our emails, and happy if you reach out to us. And there's a whole team behind the work that was done that we've showcased here. So again, I thank you for your time, and happy to take any questions that you may have.